Okay, so you want to make your first Five Nights at Freddy's horror game on Roblox. That's great. You're not the first to do it, but you're listening to me, and under my guidance, I'm gonna take you to the moon. You don't own Five Nights at Freddy's, so as courtesy, it's always nice to put a little, "Hey Scott, thank you for letting me use your assets. You're so amazing, Scott. I'm gonna give you a blow." Just something sincere, you know, to make them forget about all the copyright infringement violations you're making. It's part of Roblox. Have you seen how many versions of breaking? God, there's fucking 54. Actually getting into the development is pretty easy. Just load up Roblox Studio, open up an empty baseplate, and you're here. Great, you made it. That's awesome. Next, you're gonna wanna make an office, because every Five Nights at Freddy's game has an office. And this is the part where I should probably tell you that there are quite a few things that you'll need to know before you can follow this tutorial. I'm assuming you have a fundamental understanding of programming logic and object-oriented programming, as well as moderate experience with Roblox Studio. If you do not have any of these characteristics, why are you here? There are plenty of tutorials about these topics on the internet which are better resources than I could ever provide, so come back if you need to. Here's our office. Our office is pretty nice and tidy. It resembles the FNAF 1 office, of course. When you're building your office, make sure to keep in mind that we're only going to be making the mechanics from FNAF 1 because we're not going to put anything else that might be in the preceding FNAFs like vents and other maintenance shit. So make sure that you account for the fact that there's only going to be 2 blast doors and nothing else. One thing you two want to keep in mind while you are building, and it is good practice, is everything the player interacts with or you're going to need in the future for scripting should be grouped in its own folder so it's easier for accessing, right? In my case, I made a separate folder called Workspace Utilities, and I grouped the left panel, the right panel, right door, left door, and this hanging light, because this hanging light is going to be the thing we're going to need to turn on and off depending on whether there is power. Make sure you group those under a separate folder. I decided to name my folder Workspace Utilities. You can name it however you want it, but just make sure that you keep the name in mind. And I grouped everything else under a separate folder called Map to keep everything nice and tidy. You might be wondering, how did I make the game look like this? Number one, you want to go into lighting. You want to make sure that you select future, and you also want to change the ambience, the color shifts, and the outdoor ambience, shadow softness, etc., depending on what you want. So here are my properties alone if you want to replicate what I've done. I've also added in ambience, a sky, a bloom, color correction, depth of field, sun rays, as well as increased the FOV of the camera just to kind of get an image of how I want the game to look. So moving on from here, we need to figure out how we're going to stop the player from controlling its character. Whenever the player joins in, the standard Roblox movement and standard camera is like a third person drag camera and walk around with WASD. We want to disable this, right? We want the camera to be over here instead, completely locked so that the player cannot control it. To do this and to disable the player, we can do a couple things. We can anchor the player. You want to just enter a script in the server script service. We're going to name the script server. We're going to do everything on the server through the script. Use good documentation and segment the script off into a section called services. We're going to need to require the players service so that we can get a complete list of players. Game, get service, players. As you can see, whenever you play the game, your character is added into the workspace. Whenever this is done, we just want to anchor the player. And to do this, we need to make sure that whatever's added into the workspace is the player, because we might be adding parts into the workspace on a separate script that's not the player, so we cannot assume that everything's added to the workspace and a player in it. So workspace.childAddedListener, we're going to connect the function. We're going to have the object parameter. If object is a model, now that object fits this requirement, we can move on to the next step in detecting if it's a player. If the object's name is in the player list, then we can assume that it's a player. If PS find first child object.name, then so now that we know it's a player, all we're gonna do is object the primary part, the anchored equals true. So now every time we join the game, our character will be completely floating into the air and we cannot control him because the humanoid root part is anchored. Sweet, so we can't move. Now that we've locked the player, we can now move on to controlling the player's camera. How do we change the player's camera? Well, first off, we can't do this in the server. We're gonna need to do this in the client, and we're gonna wanna go down to starter player scripts. So we wanna load this script every time the player joins the game, put it under starter player scripts. We're gonna name this script called client. There's not much you're gonna need in this script because we're gonna use object-oriented programming to do this. Create a separate module script under this client script, and we're gonna name this camera controller. This is where we're gonna do all the operations for our camera so that it's nice and clean and follows object-oriented programming. We're gonna need a few variables and services. One, we're gonna need the run service. And also we're gonna need a few variables, the camera for now. And if you want to shorten this, you can replace game.workspace with workspace. Roblox allows you to do that. Make a separate function called camera controller enable. This method will turn the player's camera into this office camera. We can manually control it from there. So there's one more thing we also want to include, which is a constant. We're going to name this the camera render keys, because whenever we're rendering the camera with the run service, we're going to bind it by a key so that we can enable it and disable it depending on what we want. Just render camera, and that's how we're going to enable and disable this camera controller. Next up is actually deciding where we want to put the camera. Make sure you position your camera somewhere where you want the player to be looking when they first initially join the game. right there is fine. So to save this C-frame, to save this rotation position of the camera, all we're gonna need to do is run a simple command line into the execution bar right here. And if you do not see the execution bar, you can go up to the separate tab called View and click on the command bar. This command right here, all it does is create a new part, parents it to the workspace, changes the size, makes the C-frame to the current camera C-frame of the workspace, which is this camera, the camera we're using, anchors it, changes the can collide off, and then make sure the transparency is 1 so that we're not looking inside of a part. Once you run that command line, it's going to create a separate part here. We're going to rename it camera part. We're going to parent this into workspace utilities because it's an asset we're going to use. So now that we've saved the position and rotation of where we want the camera to start, now we can manually search for it in our variables, workspace utilities, wait for child, camera part. We're using wait for child because every time the player is loaded, it does not necessarily mean that they have downloaded all the data into the workspace. So if certain objects might not be loaded in quite yet, if you decide to use just workspace utilities may not have loaded in quite yet, and then it'll thus be fetching a nil object and returning a null value. So we're going to instead include wait for child so that we can get the workspace utilities once it loads in. Now that we have the part which represents the initial rotation and position of the camera we want, we're going to need to lock the camera and C-frame it to the camera part's C-frame. To do this, all we're gonna need to do is change a few properties of the camera. As you can see here, the camera properties have camera subject, camera type, and field of view. Field of view, I manually adjusted to 50. Originally, it would be 70, but as you can see, it looks a little too zoomed out. So instead, I decided to put it at 50. So these properties are gonna be the ones we are gonna change to make sure that we can lock the camera. While the camera controller is enabled, we wanna make sure these properties remain what we put them as. And to do this, we're gonna bind this separate function called local function render camera. We're gonna bind this to each frame, and we're gonna put the key, camera render key. The render priority is gonna be the camera render priority, and we're gonna do that dot value. And we're gonna put the function to run every single time a frame is ran, which is render camera. Now we can effectively change the properties of the camera and not worry about it being changed by an external source. We're gonna change the property of the camera type to enum.cameraType, that's scriptable. We're also gonna change the camera subject to nil because there is no camera subject. And we're gonna change the field of view to whatever field of view you would like. One thing we haven't done is change the camera C-frame. So that is positioned right here where we want it. We're gonna go down here, camera.C-frame equals camera part.C-frame. Before we can do that, we have to make sure, because this is a module script and this is object-oriented programming, we're gonna have to require this camera script. We're gonna say require script, wait for child, camera controller, and camera controller enable. Now that we enabled that, every time we join the game, our camera should be effectively here and we can't move. Sweet. Our camera's here, I can't move. Now we have a locked camera in the center of the office where we want the player to be viewing. In original FNAF, you can maneuver and look at the panels of the doors by moving your mouse left to right, and that'll pan the camera either left to right. Here, in my version of FNAF, I decided that that's a little bit too simple, and personally, I don't like that approach. Instead, I would like to do what I used in All Insanity Asylum and have the camera follow the mouse wherever it is on the screen and rotate it to there and make a nice fluid motion. To do this, we're gonna need to use a few mathematical operations, and I'll show you right now. Okay, so in our workspace utilities, we have this part called camera part, which represents where we're gonna C-frame the camera to. This part can be rotated on 3 axes: the y-axis, the x-axis, and then we have the z-axis. But we're not gonna be rotating it on the z-axis at all. Instead, we're gonna be only using the x and y-axis. When thinking about these axes of rotation, you wanna understand what's the most logical way it will rotate. If you think about rotating the camera amongst the y-axis, it will rotate in this motion. When you think about the x-axis, you'll think about the camera rotating around this pole in this motion. So now that we have that information, we know how to rotate the part so that the camera can also rotate because the camera is following this part. We also have our viewport, which captures what the part is seeing. When the player's mouse cursor is on the screen, we need to rotate the camera part by some value to match where the cursor is. So if the cursor was on the top right of the screen, we need to aim the camera part to the top right of the screen effectively. With this 2-dimensional rotation, we need to figure out 2 components, the X and the Y rotation. We also need to make every rotation relative to a certain point, or where the part originally is. So essentially, this point of pivot, and we can store this in a variable, will be the camera part's default position and rotation, or its C-frame. We will assume that if the cursor is in the middle of the screen, the camera's rotation should be its default or the pivot point. We can effectively view everything in a 2-dimensional sense. By this, I mean that the viewport can be viewed as a grid. If we view the center of the screen as the pivot point in the 2-dimensional screen, which is right here, the center, or where the cursor is, Then we can use the distance between the mouse and the center to find the X and Y component. Let's assume again that the mouse cursor is off in the top right of the screen. We have the center of the screen right here. So finding the distance between the center and the mouse can be plotted as a right triangle. You have the original distance, but then you also have the X and the Y components of that distance. You have the amount of X pixels it is moved away and you have the amount of Y pixels it is up from. Understanding the viewport as a grid measured by pixels, the center of the screen can be plotted by taking half of the total viewport size for the X and Y axis. It's important to note that the amount of pixels on each player's viewport is dependent on their device's resolution. So the amount of X axis pixels could be 1920. The amount of Y axis pixels could be 1080, and that would be 1920 x 1080. And that's all dependent on what the user is using, what device they are using to play the game. So effectively, the center could be then plotted as X divided by 2 and Y divided by 2. That is the ordered pair and position on the screen the center is. With the center plotted, we can get the cursor position on the viewport by using Roblox's mouse.x and mouse.y. And this will get us another ordered pair, which defines the position of the cursor right here. And then subtracting those values from the center ordered pair gives us the distance which we originally wanted. So we can store that in a separate value. We'll go distance x and distance y equals x minus the origin point, which is the viewport size.x. So camera.viewport size.x divided by 2 and y minus camera.viewport size.y divided by 2. With these two distance components for the X and Y, we can use these values for the increments of rotation for a camera part in the 3D world. So we can take these values, distance X and distance Y, and use these values to figure out the increments of rotation we want in our camera part to rotate by. Camera is effectively represented by this camera part since the C frame is set to this part here. But we can manually just change the camera C frame instead of the camera part and go from there. We will always rotate in relation to the three-dimensional pivot point we put right here, which is effectively this right. So using cframe.angles, we can write our formula as such. Camera.cframe equals pivot point times cframe.angles math.rad distance y math.rad distance x, and then 0 because we are not rotating on a z-axis. Remember how we thought about the axes of rotation. If we're rotating amongst the y-axis, it's going to go from left to right. This will rotate the camera depending on the distance between the cursor and the middle of the screen on the viewport. The camera part is essentially there to store the default C-frame from which we will pivot from. Now, the only issue here is adding boundaries so that the camera cannot rotate too far on either axis. We will implement that into Roblox. Okay, so implementing this whole idea into Roblox should be pretty easy. We already kind of went over a little bit of the code. I just want to go back into camera controller because that's where we're going to be controlling the camera. We're going to be needing to define a few other variables. We're going to need to get the local player or the player that is using the device. And to get that, we just need the player service, just how we did in the original server script. We're going to do game get services players, and we're going to create another variable called player, and that's going to be equal to ps.localPlayer. It's going to get the player using the device. And we also going to need to get the player's mouse. We're going to need to get the position of the mouse. So to get the mouse, we just use player get mouse, which is just an ingrained method that we can use. Now to control the camera, first we need to figure out how we're going to map the mouse onto the screen and the center of the screen, as we had discussed in the math section prior. So if you do not know any of this, then you probably should have watched that section. First things first, we're going to want to get the center of the screen. So center of the screen can be marked in order pair, and we're going to be using vector 2 because vector 2 stores the 2D values. So we're going to go local center post, and we're also going to need to get the mouse position. So we're going to also create another variable alongside that called mouse post. So center position is going to be equal to vector2.new. And remember, we're going to get the size of the viewport. All we need to do is a camera.viewport size.x divided by 2, then camera.viewport size.y divided by 2, and then define another vector 2 value for the mouse position. That's going to just be mouse.x, mouse.y. Sweet, we got two ordered pairs, and we can then do subtraction. So the distance in x pixels and y pixels from the mouse to the center of the screen, we're just going to create two different variables as well, which can be numerical variables. It's going to store the difference in x pixels and y pixels, and all we need to do is then define these as x distance is equal to mouse position dot x minus center position dot x, and then mouse position dot y minus center position dot y. Now that we have those distances, we need to use those distances as increments for rotation. So we're going to define the x rotation on the x-axis and the y rotation on the y-axis. Remember that when we rotate on the x-axis, the camera movement will be up and down. So we're going to need to use the y distance for that. So we're going to go math.radians y distance, and we're using radians because remember, radians are a better way for the computer to calculate angles. We're not going to be using degrees. And it's also radians is the default intake for any C-frame.angles statement. So we're going to do math.rad Y distance and then math.rad X distance because rotating on the Y axis rotates it from left to right. All you need to do is just change the camera.c-frame equals camera.c-frame to camera.c-frame equals pivot point. And remember, our pivot point is yet to be defined, but we did discuss it in the math that the pivot point is just going to be the C-frame of the camera part. So we can create another variable if you would like and just name it pivot point equals camera parts.c-frame, or you could just directly change pivot point, replace it with camera part.c-frame. Either way is up to you, but for the sake of documentation, maybe reading it more like English, we're just going to call it pivot point as a separate variable, and then we're going to need to multiply it by c-frame.angles, which allows us to rotate it, and we're going to put the X rotation, Y rotation, and then 0 because we're not rotating it on the Z-axis. Sweet. So now whenever we play the game, our camera should follow our mouse, not necessarily follow it, but rotate it. If we move our mouse kind of to the center screen, you can see how it moves to the original position we set it in on the camera part. As you can see, it's very choppy. It can move in 360 degrees on either axis, so we get this weird rotation. It moves very quickly. You move your mouse like, let's say, about 1 inch to the right. It's also moving to the left about like 90 degrees, and that's not okay. We want to scale it down so that instead of every 1 pixel is 1 rotation, about every 100 pixels is 1 rotation, so that it takes a little bit more mouse movement to rotate more degrees. Also notice that it's inversed, and there are no boundaries set to the rotation, so we can just rotate all over the place. So those are the things we're going to need to do. Let's scale it down so that instead of 1 pixel equals 1 degree rotation, you can pick an arbitrary value like 100 pixels equals 1 degree rotation. But there's one thing you do want to keep in mind, and this is the problem that some people might have, is that when you're using set values for pixels, which are dependent on the user's resolution, then sometimes, right, on a smaller device, 100 pixels might make up 1/7 of the player's screen. And 1/7, if you dissect a screen into 7 sections, 1/7 is a huge distance just to move 1 degree. So you need to have a value instead of a set arbitrary value like 100 pixels. You need to have a value that scales with the user's resolution. And to do that, we can just take a percentage of the user's resolution rather than a set value so that it is constant no matter the user's resolution. So for instance, if we're going to change the X rotation and the Y rotation to be scaled by something, we could say X rotation divided by cam.viewportsize.x multiplied by 0.01, which means that we're going to get 1% of the viewport size in the x-axis, which equals to 1 degree of rotation, instead of maybe doing it per 100 pixels, because if we just divide that by 100, then it doesn't scale with the user's resolution, and we could be dealing with a much smaller resolution, maybe on somebody's phone, and therefore they won't be able to move and see as much as we would like them to. So instead, use the percentage of the screen so that it scales with the user's device and what their resolution is. I'm also going to need to translate that over to the Y rotation. So Y rotation by the cam.viewport size.y multiplied by 0.01. which is just 1% of that. So now when we play, it should be scaled no matter the user's resolution. And we also can see it takes a little bit more mouse movement to rotate it. We can't rotate it nearly as far, but we can still rotate it too far, so we're gonna still need to make the boundaries for it. And it's inversed as well. But as you can see, if I were to move the screen, move the viewport size to make it much smaller, it doesn't quite matter. It's still scaled appropriately because we are using percentages rather than a set value. Moving on from scaling it, we also need to set boundaries to the rotations on both axes. So to do that, we're gonna be using a math.clamp function. And this math.clamp function takes in an input, we're gonna say X, and then it takes in the minimum amount it can be, so like -1, and the maximum amount it can be in like 1. So math.clamp basically returns X if it is equal, if it's between -1 and 1, or it will return -1 if X is below -1, and it will return 1 if X is greater than 1. This allows us to make sure that our rotations won't rotate outside of a certain boundary, and we can just write this as such, math.clamp X rotation, and we're gonna be using radians. Make sure you type in the values with math.rad. We're gonna clamp it by -90 and 90 degrees, so we get a rotation of 180 degrees, and then for the Y rotation, which is left and right, clamp it by -60 and 60. Now these values and boundaries are adjustable to your own liking depending on how your map is or how much you want them to view, but just know that increasing these values on either ends just makes it more degree of rotation so that they can maybe go further up and down or further left and right. So now that we have that, we shouldn't be able to move it too far to the left or to the right. See, it will stop us. And this will also apply even if we change our viewport size to very small, we still can't rotate too far left and right. Sweet. So one last thing is, as you might have noticed while we were moving that camera, our movement is inverse. So when we move to the left, the camera is moving to the right. So just to make sure that it follows correctly, we're just gonna make the rotations inversed. So X Y equals -X rotation and then -Y rotation. And then that will effectively inverse our rotation so that it matches with the movement of the mouse. And we have a little nice movement like this. So amazing. We can move left, right, up, down. And this is the type of movement we were originally discussing. So instead of the traditional go left to right to pan it, we have like a little cooler effect. You might not like this better than what FNAF did. And if you want to do what FNAF did, it's pretty easy. The logic is just if the mouse is on a certain section of your left screen, then pan the camera to the left. Or if it's about this little section of your screen, then pan the camera to the right. And that's generally the idea you would do if you wanted to do that camera function. Now that we've done the camera, there's only a few more things to do to make the player. We're going to need to be able to control these doors and these lights, and to do that it's just pretty easy. We'll be using click detectors, and those are all event functions. No math needed anymore, so make sure that you just follow along. Okay, so to create the blast doors as well as the corresponding hallway lights, we're going to create two separate parts, one called the left hallway light and one called the right hallway light. Within each one of these parts, it's going to have a spotlight and a sound object called hum. The hum is just going to have the distinct FNAF fluorescent hum sound that you hear like this. Make sure that it's looped and we'll play it on and off depending on whether the light is on. We're also going to modify the panels here to have click detectors in each one of the buttons. So we'll attach a click detector to the door button as well as the light button for both panels and change the max activation distance to something large like 1,000 studs. Now, if your blast door models are models, so made up of multiple parts, then follow these steps because you cannot tween a model's position. Instead, you have to tween one part's position and then weld everything else onto that part so that it moves along with it. So find one base part, I call it the root part, and I renamed it as the root. Also put a sound object called the door movement. This is going to be that infamous door sound of opening and closing. That type of sound. I just put that in there and also weld each other part to that door part. I usually use a plugin for this. This is called the welding plugin. You can find this on the Roblox store. If not, you can do it manually by inserting welds yourself. Once you have all that welded, if you're using models for the blast doors, we should be good to move on into the scripting portion of this game. Go down into client, insert a module script. We're going to be creating a new game object. So rename this module script to game. The object-oriented creation process on Roblox is a little bit different than other programming languages, but you should know how to do this because I did emphasize that it was a pre-requirement before getting to this tutorial that you should have this knowledge. But if you do not know, just follow along, and then we're going to have a game.new function, which will create our object whenever that is invoked. We're going to say local self equals set meta table, empty brackets game, and then return self to return our object. We can assign properties and methods to it, which we'll do future, but for now, let's just do a quick property called power, and that's going to be 100. Next up, we're going to also want to create another object here under the game script and label this as panel. The panel will be the object which controls both the light and the blast door, depending on which side the panel is, so it can be left or right. Make this panel an object with the same process we did prior for the game object, but unlike the game object, we're going to have a parameter into the creation process or the .new function. We're going to have this parameter be labeled panel type, and it's going to be string. And this panel type is going to be either the string left or the string right, because having it defined as either the left panel or the right panel allows us to define the parts for the left blast door or the right blast door, the left hallway light or the right hallway light. So having that distinction matters. Now that we've done that, just finish off with this local self equals set meta table. Now that we've created that object, let's assign some properties to it. Before we do assign any more properties onto our object here, I'll go up to the first line and let's create a variable section for good documentation. Let's create another variable called workspace utilities because we will be accessing the workspace utilities folder for some of those parts like the right door or the right hallway light. So now we can define the property here for the new panel object. We're going to say the self.panel is equal to workspace utilities, find first child, panel type, panel. It will just retrieve the either right or left panel depending on what the panel type is. We're also going to want to get the individual buttons in the panel, which will be the door button and the light button. Also going to need to retrieve the blast door. So let's do self.blast door equals workspace utilities and then self.hallway light equals workspace utilities. So those are all the objects in workspace we're going to need to retrieve for the corresponding panel. There are a few more things we want to include. For instance, we're going to need to define connections within our object for the individual click detectors within these buttons. So we're going to label these two properties here as self.blast door connection and self.light connection. This is so we can disconnect the click detector just in case the game ended or we want to disable the lights. For example, if we have 0 power. We also want to have two other variables which dictate whether or not the blast door is up and down or whether or not the lights are on or off. So that's going to be blast door status and self.light status. We're going to put these as both false and false. And when it is false, it is going to be when the door is opened or when the light is off. Next up, we're going to want to create a new method called panel bind buttons. This is where we're going to assign the click detector functions for these buttons here for the door button and the light button. Before we do that though, there is a service we're going to need for this, and it's going to be the tween service. Get the tween service by doing game get service tween service. Gonna also need a tween info object to define the tween we want to put on the blast door. So let's just define a variable here called blast door tween info and change the time it takes for the blast door to open and close to about 1/4 of a second. And then our easing style will be linear and our easing direction is out. You can adjust that to your own liking, but for now, just keep it as that if you're following along. Let's come back down to the bind buttons. We're going to create the connections for these click detectors here. So we're going to define the blast door connection as so. Self.door button, click detector, mouse click, connect function. So this is where we're going to open and close our doors. First, we're going to detect whether or not doors are already closed or if it's open, and that's going to be using the self.blast door status we previously defined here. So if self.blast door status is equal to true, then that means it is opened. So we're going to close the blast door with this if statement here. We'll just put a ... for now. Else the blast door status is equal to false, then that means we're going to need to open the blast door. So we're going to put the tween here. Let's also define the light connection equals self.light button, click detector, mouse click, connect function, just how we have done with the blast door connection. Now that we've done that, let's just real quick finish up with this blast door connection here by actually creating the tween. But before we do the tween, the opening and closing sound should play each time. So let's just get that sound object by doing self blast door root door movement. We're stopping the sound object just in case the sound is already playing, so we can start it from the beginning rather than play it from wherever it is. We're going to go self.blast door movement playing. True. So that should play that sound every single time that button is interacted with. Now for the closing portion, let's just create a tween. So self.blastdoor.root blast door tween info We're going to change the C-frame of this door here, but we don't know quite yet what is the door's position when it is open or closed. So we need to find that values here. And we can go down to these values by using the origin position here and finding the Y value it is at when it's closed. So that's going to be 4.15. Let's define that into a separate variable here. It's going to be a constant. Make that segmentation here. We're going to label this as door closed Y and then door opened Y, because we'll find that eventually. So 4.15 for our closed Y value. And then if we move the model upwards to about however height we want it to be when it's opened, I see 1215 for our Y value when it is open. Now define that for the door opened Y. So now that we have that, we need to also understand one more crucial part about C-framing. Because we are changing the C-frame, that also means we need to define the orientation for the part. Although our parts are predetermined and we know the orientation for each part, so we can just get the orientation. Say we go to the right door, we look down here and say the orientation is -180, or go to the left door and see right here the orientation is 0, 0, 0. We can predefine that and say, okay, if it is the left door, then change the orientation to 0, 0, 0. If it is the right door, then change the orientation to -180. But we don't need to do that if we just do the simple concept by multiplying the C-frame by the rotation of the original part and getting the rotation of this part. All we need to do is get the C-frame, subtract the position from the C-frame, and it'll leave us with just the orientation. So just to write it down and you might get a better understanding of this, we're going to say that C-frame is equal to C-frame.new. We're going to define it as a vector3 value since it is a position we are changing. We're going to say it is equal to self.blastdoor dot root dot position dot x, since that won't change, but the Y is changing, and we're closing it. Use the door closed Y value we just defined here, and then self.blastdoor dot root dot position dot z. So this C-frame here will just give us a standard C-frame with the position that we define here with this vector3, but an orientation of 0, 0, 0 as default, because we did not define its orientation. So to define its orientation, we can multiply the C-frame by C-frame.angles, like we have done with the camera, and multiply it by whatever the orientation of the original part is. And to get the orientation, we actually don't need the C-frame.angle statement here. What we can do is we can do self.blastdoor.root.C-frame minus self.blastdoor.root.position, because when you are subtracting the position element from the C-frame, all you are left with is the orientation for the C-frame. So that will just give us the -180 if it was on the right door on the Y-axis rotation. Say we are using the right door, for example. This is just equal to multiplied by C-frame.angles 0 math.rad -180 and 0, because it is just getting the orientation element of the C-frame. So these are only equal if it is the right door, but it changes if it is the left door, because as you can see, the orientation is 0, 0, 0. Nice, so now that we have that understanding, let's just play the tween whenever that happens. We need to also create the tween for when the door is closing. So let's do that here. I'll just copy and paste here and then change the Y value to opened Y. Now that we've done that, we can observe whether our script is working by creating a new game object within the client. So let's just go to the client and say local new game equals script wait for child game. And we also need to require this to say there's a module script. We're going to do the .new function here, and we're going to do new game start. This is a method we haven't defined yet, so let's define it here. One other thing, we need to create the left panel and the right panel. But now that we have the panel object, we can do that. So just go up here, define a separate variable, go local panel equals require script wait for child panel. And now we can just use the panel object to do the .new left panel .new right. So now we create the left and right panel. And now let's do the method here for startup game start, and let's go self.left panel bind buttons, and then self.right panel bind buttons. Now we can play the game and test whether our doors are opening and closing as they should. Ooh, we have a problem here. Oh, I accidentally put the wrong value, and I accidentally put the comma when I meant to put 1215. All right, so now that we've done that, we should be able to click on our door. Ooh, index nil with root. I misspelled blast door, so let's change that. Sorry about that. So now whenever we press this and click this, it should open up and down, but it is not closing. That is because we forgot to change the status here. So the store status will always stay false if we don't change it. So let's just do self.blastDoorStatus equals not self.blastDoorStatus. And the not keyword here just means that it is going to change the Boolean to the value that's opposite of what it is. So if it is false, it's going to change it to true. If it is true, it's going to change it to false. This is a simpler way of writing it as an if statement, because if this was an if statement, we'd have to write it like so. If self.blastDoorStatus equals true, then self.blastDoorStatus equals false. Else if self.blastDoorStatus equals false, then self.blastDoorStatus equals true. And saving us, 5 lines, we can just write it as this line right here, self.blastDoorStatus equals not self.blastDoorStatus. So now we can open and close it. This should work here. Sweet, we can open and close both doors. Amazing. The one thing we cannot do yet is change the lights. Great. Moving on to the lights. This should be fairly simple. We're not using any tweenings. All we're doing is changing the properties. So as with the blast door, let's just do an if statement, self.lightStatus. If self.lightStatus equals to true, that means that the light is on, then we're going to turn it off. Else the light status is equal to false, we're going to turn the light on. To turn the light off, we just need to stop the humming sound as well as enable the spotlight. So I'll just do that by doing self.hallway light dot hum stop and self.hallway light dot spotlight dot enables equals false. Turn on, just do the exact opposite. So just copy and paste this code here. Say hum.playing equals true and spotlight enabled equals true, and then wrap that all up. Let's change the Boolean for the light status. So self.lightStatus equals not self.lightStatus. So now that when we play the game, we should be able to click on the light button and it should activate our light. Now what you might notice is that in FNAF 1, when you click on the light, it flickers. When it's on, it does a little bit of a buzz and it flickers on and off randomly. We can accomplish this by just adding a separate method within our script here. We're gonna do a separate method called function panel flicker light. Flicker light function is gonna have a local function inside of it, and we're gonna name it flicker light, and we're gonna have a while loop for it. We're gonna go while true and pass.wait do. So this loop can be running until the game is eventually closed. If you don't want that to happen, you can create a separate variable here, which is self.flickering light boolean, and we can say that equals false. And so that when we change to this boolean, we can say while self.flickering light, let's change self.flickering light boolean here. So now we have a boolean which kind of controls whether this loop is active or not with this attribute that we've created here. Moving on to what actually matters, which is the interval at which we're going to wait for the flicker to happen. We want this to be at random intervals. So we're just going to use a task.wait function here. We're going to go interval between, let's say, 50, 500. We cannot include decimals into a math.random function. And because of that, I'm just going to go around it by using a multiplication of decimals, so that instead of it being 50 seconds to 500 seconds, it will be 0.5. So 1/2 a second to 5 seconds is the random interval we're working with. And also before we do rate that interval, we want to make sure that the light is on. So if not self.light status, then continue, and this continue here, if you have not worked with this before, just means that if this condition is met, so if self.light status is equal to false, then it will continue over, or it will ignore everything else in code that's following it. So if it is false, it will not wait this interval, meaning that if the light is off, then it won't wait the interval. It'll just keep looping and looping and looping and repeating itself until the light status is on. Let's just copy and paste the statement and push it down here too, because every time we wait a certain amount of time, there's always a possibility that the player turned the light off. So we always need to have this condition check here to make sure that the light is still on, so that we can flicker. Now, flickering can happen like once or twice or 3 times at the same time. So to have a random amount of flickering happen, let's just nest another loop within this loop. And let's say for n equals 1 through math.random, 1 to 3 flickering intervals. Just copy and paste this line of code down here to turn it off. And we're going to wait a random amount of time to turn it back on. So just do math.random 5 and 25, that'll be our interval, multiplied by 0.01, which means that the minimum will be 0.05 to 1/4 of a second, and then we'll turn the light on. So just copy and paste this line of code here, and then we're gonna wait yet another random amount of time. But every time we do waits, remember, we need to do this condition check, so just copy and paste this condition check under these waits here. And to top it all off, or to finish it up, we need to actually call this function. Now, we can't just call this function like this, because if we call this function like this, that means that whenever we use the flicker lights function down in our code over here, so let's say we put it right here, that means any code preceding it can't fire, because this loop function will not end. And since this loop function will not end, no code in front of this will fire. So this print statement won't fire if we do not do anything about this while loop here, and we just call it as it is. To combat this, what we can do is we can use quarantines. I'm not pronouncing that right, but that's okay. Quarantines basically means that we can run this loop on a separate thread. So it's not running within sequence of our code here, it's running on a separate thread. So to do that, all we need to do is just quarantine.wrap flicker lights, redefining the function here. And we're going to call this new threaded version flicker light. So now that when we call it here, we can also get this print statement that we had defined, hello world. But I don't need to show you guys that. You guys should be smart enough to understand. Now that we have this flickering light, we can actually see it in game. Oh, look at that. Whoa, whoa, it's flickering. Random flickers. Isn't that crazy? And even if we turn it on or off, right? When it's flickering, if we turn it off, it turns off permanently, right? It doesn't flicker back on. That's because we have those condition checks. Great. We have the lights and the blast doors. That's pretty much it for the player. Players other than the cameras, of course. We haven't built the entire pizzeria. We don't have positions where the cameras to be, and we don't have the UI for the power quite yet. But what we do have is a nice little showcase where you can open and close doors, turn lights on and off. This is a nice foundation. If you made it this far, congrats. This tutorial introduces you to a very bare bones version of FNAF. There's tons of customization available to you, and using these same principles in object-oriented programming, you can use these mechanics to do other things like ventilations or other aspects of FNAF games that you might know. So just use this knowledge. I'm gonna make part 2 available to you guys as soon as I can, but make sure you smash that like button. Anyways, continue with the tutorial. So that brings us to the end of part 1 of this tutorial on how to make your own FNAF game. I'm just gonna use the rest of this time to plug my own shit. If you wanna play a FNAF game that's already out and you haven't played this, go check out Forgotten Memories on Roblox. It's not your typical FNAF, it's a free roam FNAF. Check it out, updates coming soon, I swear. And then if you want part 2, smash that like button, subscribe. If we can get 15 likes, I will consider making a part 2 and putting myself through this hell of recording and editing. God, that was a long time, but hope you enjoyed. You have yourself a good day. Peace.